Hello everybody. Today we're gonna talk about some fun facts about root 2 and how to prove that root 2 is an irrational number. To start with, I want to share to you an interesting fact about root 2. It all starts with this ordinary piece of A4 paper. So what's interesting about that is that when you measure to the long edge of this paper and measure the short edge of this paper, if you divide the long edge by the short edge, what you get, that's root 2. And more interesting is that if you fold this A4 paper into half, this gives you an A5 paper. And now if you measure the long edge of this A5 paper and then divide it by the short edge of this A5 paper, again you will get root 2. So talking about root 2, the story goes way back to the ancient Greece time. A group of people called Pythagoreans. They believed that everything in this world is made up of maths and numbers. And so one day a guy called Hippasus, he worked out that to prove that root 2 isn't a ratio of two integers. That means root 2 cannot be written as a ratio of two integers. And that is the irrational numbers today. So to prove that root 2 is irrational, we will first have to assume the opposite. That is, root 2 is rational. So what means by root 2 is rational is that root 2 can be written into a fraction with a over b. That is, a and b are integers. It can't be decimals, it can't be other fractions. That has to be whole numbers. And we also assume that a over b is already the simplest fraction. Because you know that every fraction can have the simplest form, that means that a and b should share no common factors other than 1. So we have root 2 equals a over b. Now we take square on both sides and we get a squared over b squared equals 2. We change the signs and take the square. So now if we move this b squared to the right side, we get a squared equals 2b squared. That means that we can see that a squared is an even number because a squared has the factor of 2. So a squared is even. So now think about it. If a squared is even, can a be odd? The answer is no, because if a is odd, an odd number multiplied by himself another odd number, it will still be an odd number. So a is also even. Then we let a equals to 2 times c, because a is an even number, so it has factor c. It has factor 2 and also another factor c, but this is not important because we just have to know that a is even and c is also an integer. And now we substitute a equals to 2c into this original equation and we get 2c whole square equals to 2b squared, and then we put the square inside, we get 4c squared equals to 2b squared, and that means b squared equals to 2c. We divide both sides by 2 and then change the signs. And b squared equals to 2 times c squared. That's the same as before, the previous proof. We can know that b squared is even and then also b is even. Now what we get is that a is even and b is even. So what's the problem? We have a problem, right? So do you still remember our assumption? We have assumed that a and b should share no common factors other than 1. But now we got a and b are both even, which is a contradiction to our assumption. So we know that a and b, a over b is an impossible fraction. It does not exist. So root 2 cannot be rational. It can only be irrational. So that's all for the proof of root 2 to be irrational. Now can you try and prove that root 3 is also irrational?